In our last unit, we are going to talk about what are known as sequences and series. What this will start leading us into is just a kind of a fundamental understanding of limits. Actually, now there is a specific reason why I actually have it written in cursive. It does start dealing into some calculus bit, but we'll kind of deal with that a little bit later on. It's kind of by itself, it's kind of its own entity within Pre-Calc 20. So we have our curriculum, kind of what I expect you want to be able to do. And our first section talks about what are known as arithmetic sequences. So the first thing that we're going to do is describe some patterns that are happening here. For example, 1, 4, 7, 10. Well, if we're looking at this, we're noticing every single time we go to the next number, we're adding 3 to it. In other words, it's going up by 3 each time. 1, 4, 7, 10. Logically, our next number would be 13, then 16, and so forth. If we look at the next one, it's also going up by a consistent amount. In this case, it's going up by 6. If we go to the next one, 2, 4, 6, 8, the next logical step would be, who do you appreciate? I pause for laughter. And now, of course, logically, this is going up by 2. We're adding 2 each time. Now, each and every single one of these have something very common or something very similar to them, among them. They're all going up by a certain predetermined amount. And that's what an arithmetic sequence is. An arithmetic sequence is where the difference between consecutive terms is constant. In other words, if you take the common difference is taken by taking the difference between successive terms. So if we look at this first one, 7 subtract 4 is 3. 4 subtract 1 is 3. 11 subtract 5 is 6. 17 subtract 11 is also 6. So they're going up by a consistent amount. Of course, we can look at it, but we also have to look at it in terms of what the difference is. What is happening to go from the first to the second? Well, we just have to take the second and subtract the first, or the third subtract the second, the fourth subtract the third. Because our next logical step in this one would be 23. Our next logical step here would be 10, 12, 14. So let's look at some questions here, see whether they are actually arithmetic sequences. 2, 6, 10, 14, 18. If we're looking at this, just from kind of more elementary bit, we're seeing we go from one step to the next. We're going up by 4 each time. And it is consistent among every single one of these numbers. What we want to really get into the habit of is seeing that, yes, 18 subtract 14 is 4. Because we take one number and subtract the number right before it. Or we take 14 and subtract 10. It also being 4. And that would continue on with every single one of these numbers. So our difference between them is 4. If it is consistent among the entire pattern, yes. It is an arithmetic sequence. I guess arithmetic, obviously different people pronounce it differently. So let's look at the next one. 100, 90, 80, 70. Well, if we're looking at this, In order to go from 1 to the next, we are subtracting 10. Every single time to get to the next number is subtract 10. So the next number will be 60, then 50, 40, 30. So if we look at what our difference is, again, we just have to take one number and subtract the number before it. 70 subtract 80 is negative 10. 80 subtract 90 is also negative 10. So this difference is actually negative 10. Just because our difference is negative doesn't mean it's not an arithmetic sequence. This one still is, because it is still a constant difference. Every single time we take 90 subtract 100, it's still going to give us negative 10. So therefore, this one is also an arithmetic sequence. Let's look at the next one. Negative 2, 4, negative 8, 16, negative 32. If we look at it, there is actually a typo here. There should have some dots on here. On both of those. A little bit of a Freudian slip there. But in order to go from negative 2 to 4, this would actually be multiplying by negative 2. To go from 4 to negative 8, that would also be multiplying by negative 2. Negative 8 to 16, multiplied by negative 2. 16 to third, negative 32, that's multiplying by negative 2. In order for something to be an arithmetic sequence, we need to subtract. So if I were to take negative 32 and subtract 16, I get negative 48. If I take 16 and I subtract negative 8, I get positive 24. If I take negative 8 and subtract 4, I get negative 12. If I take 4 and subtract negative 2, I get 6. This is not constant. Therefore, this is not an arithmetic sequence. And our last example here, 6, 7, 9, 12, 16, 21. So you can see the pattern here. This one's going up by 1, and then it's going up by 2, then up by 3, up by 4, up by 5. But because this is not consistent, these numbers are not a constant value. This is also not an arithmetic sequence. So that's just kind of a quick way. You don't have to do all these calculations to determine whether something's an arithmetic sequence or not. It just helps to prove those facts. But this one definitely is not. Even though it does look like something very nice and consistent, it's not considered an arithmetic sequence. At the same time, I just want to make a little note about this third one. We will talk about this multiplication by negative 2 being something consistent, but that's something not done for until section 3. Well, again, we will talk about it. So to find out some terms, so to find out some stuff, this is the formula for an arithmetic sequence. Obviously, yes, you will be given the formula, but you just have to know how to use it. Now, I'm actually going to go backwards in here to describe what each of these variables mean. The D stands for the difference. And in order to find out the difference, in other words, it's asking, what is the change in D? Now, you might know that that delta is very related to your physical science and your physics and your chemistry, where it's just talking about change in. Since it's talking about the difference, what it is doing, it is finding what is the second term, subtracting a first term, or it could be third subtracting second. It could be the seventh subtracting the sixth. So all of those mean the exact same thing. They are just talking about the difference between one term and the next consecutive number. The n value is just talking about the term number. So whatever term, it could be the 7th, could be the third, could be the trillionth. No, we're not going to go quite that high, but it's just the term number. Similarly, T1 is actually the first term. 1 for term, or which number it is, and T for the term, which leads us into this kind of ambiguous variable here, Tn. It's talking about the general term. Now, the general term essentially is meaning any kind of term that you want. So instead of saying T7, which we can find out term 7, which means that that would just be the same value, we use as what's known as the nth term, or the general term. We are looking for just something that we don't know. We don't know which term we're looking for. And we'll see this into perspective. I just want to point out one thing, that this n and this n are the exact same thing. So if I use 7, that would also be 7 there. So in the context of the question, it would be asking what's term 7? Well, it would just be the first term plus 7 subtract 1 multiplied by the difference. So let's see some questions that help relate to that. So there are many factors that affect the growth of a child. Medical and health officials encourage parents to keep track of their child's growth. The general guideline for the growth and height of a child between the ages of 3 years and 10 years is an average increase of about 5 centimeters per year. Now, supposing a child was 70 centimeters tall at age 3, we're going to write this simplified general term that we could use to estimate what the child's height would be at any age between 3 and 10. So in other words, we're using the general term formula. I'm just going to put the D in some parentheses. So the general term. In other words, we're looking for what is Tn. What we then need to do is plug values in for our T1, our N, and our D. T1 stands for the first term. So in other words, what is the height at year 1? And it's actually said directly in the question. Suppose a child was 70 centimeters tall at age 3, because we're going to find out the formula for the height of children from 3 to 10 years. Age 3 is year 1 for this formula. The reason why it's using for 3 is because from the ages of 0 to 3, there's some very sporadic growth spurts that happen. Now, 70 centimeters is kind of generally average, but at the same time, it depends on child and lineage and genealogy and all that kind of idea. But let's just say the child is 70 centimeters tall at the age of 3. So let's find out what would be the height at any height in between 3 and 10. So term 1 is asking what's the height in year 1. In this case, it's 70. Here is actually the tricky part. To find out the general term, remember on the front page when I said that this n is the same as this n? Well, since we're just using the general term, this n actually has to stay as n, because we don't know what n that is. So that n has to stay the exact same in both positions. Subtract 1, and then finding out our difference. What is the difference? How much is something changing from year to year, or from consecutive number to consecutive number? Obviously, if they're 70 centimeters tall and it's increasing by 5 centimeters per year, the next year they'd be 75, and then 80, then 85, 90, 95, 100 centimeters. So a difference is actually just 5. But that's not the finish of this question. We're going to simplify this because we know how to work our grade 8 distribution. Take n times 5 and negative 1 times 5. Tn will be 70 plus n times 5 being 5n. Negative 1 times 5 is negative 5. To combine our like terms, 70 minus 5, 65, and 5n. Of course, if you want to rearrange it, absolutely go for it. Typically, I'll put my variable in front. But overall, I don't care which one you use because they are the same. Now let's just do a quick check. For year one at the age of 3, let's see if we plug a 1 into here. Is that going to give us 70? 5 times 1 is 5 plus 65. Oh, yeah, that's 70. The reason I just did that is because I'm going to set up for this question. How tall is a child expected to be at age 10? Well, that does not mean this. So don't write this quite yet. Age 10, well, you'd think we would be putting 10 in for n. 5 times 10 plus 65. No, that's not the case. Because year 1 is the age of 3. So we need to find out what year is the age of 10. Well, age 3 is 1. 4 would be year 2. 5 would be 3. 6 would be 4. 7 would be 5. 8 would be 6. The age of 9 would be 7. The age of 10 would be 8. So I'm just going to change one little thing here. Term 8 is what we're looking for. This is what you can write. So term 8, which means the age of 10 is what we're looking for. 5 times 8 is 40, plus 65 would be 105 centimeters. Or if you want to go into a little more specifics, it would be 1.05 meters. So 5 centimeters over that meter stick. So let's take a look at some stuff. For the arithmetic sequence 3, 10, 17, 24, we're going to determine what is term 15. Now, instead of actually counting everything up, let's use our formula. Let's find out our stuff. So again, our equation is Tn equals T1 plus n subtract 1 multiplied by the d. In this case, we are determining what is term 15. Well, that 15 looks a little bit weird. It must mean more than just the 15. One thing I didn't make note of is that that's not t times 8 or t times 15. It is 15, which means 15 also fits some other place in this equation. Just like I said, this n is the same as this n, which means in our question, 15 is n. I'm just going to leave a little bit of space for just a second. 15 subtract 1. So the first thing that we need to do is find out what is term 1. And sometimes it can be really simple. In this case, it's 3. So term 1 is just 3. And what about d? Well, our difference is asking how much is this going up by each time. 3 to 10. So I'm just going to do that as a kind of side note. What's term 2 subtracting term 1? That is finding what our difference is, or our change in our terms. In this case, 10 subtract 3 is 7. Now, overall, I wouldn't expect you to do this kind of step by step. I'm just doing it just because I don't have my calculator set up. I might quickly go grab it for our next example. The 15 subtract 1 is in brackets, so it's 14 times 7. 14 times 7 should be 98. So it means it should be 101 if I'm doing my math right. And I'm just going to quickly go grab my calculator. Yeah, all right. So how about determining the amount of terms when the last term has a value of 220? So this is the question is, we don't know, in this question, we don't even know what n is. So overall, you might be looking at this and saying, well, we actually have two unknowns. We don't know what this. We know what term 1 is, because it's just, this is A, B. We know what A is, we know what D is. So let's plug those things in first. So we know that term 1 is 3. We are trying to find out the amount of terms. So we're trying to find out what is n. We know that our difference in this case is 7. But we don't know what Tn is. Well, overall, we actually do. Because we're trying to find out the amount of terms. We're trying to find out what is n when that last term is 220. So in other words, we're trying to find out that n, what term number is 220. That just means our Tn. We don't know which term number it is, but that's the point. We're trying to find out what is that n. From there, we just have to manipulate the equation. I'm going to kind of combine two steps in one, just for a little bit of some fun. The first thing I'm going to do is I'm going to subtract that 3. There's multiple ways of doing it. I'll do it kind of separately on this side, and we'll still get the same answer. That'd be 217 equals, and then subtract 1 times by 7. So we can then divide both sides by 7. And 217 divided by 7 is 31. Add the 2, add the 1. Wow. Make that actually look like a 1, because it's supposed to be 1. I'm thinking of what the answer already is. N would be 32. Of course, we can quickly check that. If we plug 32 minus 1, that's 31. So 31 times 7. And we'd be adding the 3 to it, is 220. The second way that this could be done is using this exact same amount of work. 220 is 3 plus an n subtract 1 times by 7. It would be distributing that 7 inside. So 220, 3 plus 7n subtract 7. So we could have 220 equaling a 7n. 3 and negative 7 will be negative 4. So we'd have to add a 4 over. So we'd have 224 equals 7n. Divide by the 7. And 224 divided by 7. Oh, looky, looky. And it's still 32. So either way, whichever kind of makes the most sense to you, that's the way that you can solve it. So here we're going to take a question. I'm just going to scroll down quite a bit further. depending on year, I might change my questions. So depending on which year you're watching this, don't pay attention to these, pay attention to the questions on your actual handout. We're going to find term 1 when we have two terms already. You know that term 4 is -4 and term 7 is 23. Now, overall, this doesn't look like we have a lot of information. So I'm just going to write down the formula again, just so we get comfortable with it. Individually, we don't know a lot. But when we are able to combine them together, that's when we can actually find out a lot more information. So what we are going to do is we're going to actually write down this formula 2 times. Because both of these questions give us a little bit more information. Or sorry, both of these bits of information, the -4 and the 23. For example, we know that term 4, the number term 4, is -4. We don't know what T1 is, but we do know what the n is. The n value is this, it's that 4. We also don't know what D is. The beautiful thing is we don't need to know anything more here. Not yet. I'm just going to do a little bit of simplification. 4 subtract 1 is 3. So -4 is term 1 plus 3 times whatever that difference is. Now, obviously, we'd have to see that term 1 is actually something in the negatives because that's the only way that this would work, especially going from -4 all the way up to 23. Looking at this one, we know that term n, so term 7, well, we know what term 7 is. Again, I'm going to do another erase. Term 7 is 23. But even in this case, we still don't know what term 1 is. We do know what n is. It's 7. But we don't know what d is. Once again, we're going to simplify here. Term 1 plus 6 times d. Now these questions are starting to look a little more similar. -4 equals term 1 plus 3d, and 23 equals term 1 plus 60. This is one of those skills that we had learned a little bit earlier on with our quadratics, is to be able to combine our work. Now, overall, it's going to make a lot more sense to try and solve for one thing than the other. So here, let's go through this. We're going to actually have to solve for what our difference is before we can even plug it into our term 1. Now, it doesn't matter which one you work with first. For example, I'm actually going to work with this one just because these numbers are a little bit smaller. I could also work with these ones. What I'm going to do is I'm going to subtract this 3d. So term 1 is the same as -4 subtract 3d. So where is that going to come into? This can now be put right into there. Term 1 is -4 subtract 3d. It's all in the same question, so it doesn't matter where it gets put. Term 1 is -4 subtract 3d. And we still have that add 60 at the end. Then we can start with multiple. We'll start with combining our like terms. So 23 would be -4. Negative 3d plus 6d would be adding 3d. Combine or do some isolation. I would want to add the 4 over, get myself to 27, would be 3d, divide by the 3. And d equals 9. Well, where does that help us? We can now take this d and plug it in over here to find out what term 1 is. Because term 1 is -4. Subtracting 3 times by our d value, which is 9. You plug it straight in, 3 times 9 is 27, so -4 subtract 27. Term 1 is -31. So just as a nice little check, because we can actually do this relatively well, if our first number is -31 and our difference is 9, that means our next number will be -22, then -13. Difference are just going to be adding it. -4. Oh, there's term 4. Add 9 more. That should be, no, that's 11, sorry. Oh no, oh, sorry, I'm getting ahead of myself. 5, then 12. Oh, wow, I'm not doing my stuff right. Okay, 5, 14, then 23. There we go. Term 7 is 23, so there's our little check. All right, from there, I'll allow you to go have some fun.